All right, we're going to convert this equation, r cosine theta, into rectangular. And actually, this is in polar. And we're going to try to get it to see what it looks like on the xy plane. You're going to have to get a little familiar with curves that are going to look in this forms with r's and thetas. So again, I mean, you can start plotting, picking angles like 0 would give us 1, then go pi over 4 or pi over 3 and so on. But there is other ways to do this, just because we know a couple rules with the last section that we did. Like if I go back up, right, you remember these rules that we had before from trig. So try to take a look at that, and that'll help us with this conversion right here. So the first thing I want to do is let's multiply both right and left side by r. Now the reason why I did that was because we know that r squared is equal to x squared plus y squared. Try to remember that, very important. Okay, so we could change this to x squared plus y squared. Now r cosine theta, right, if we go back to up to that triangle, that will just be your x coordinate. Just remember, because cosine theta is going to be x over r, or x is equal to r cosine theta. Again, these are some basic trig, triangle trig, unit circle trig, things that are going to be useful. Now what does this look like? Well, because we have this portion where x and y are squared, it is either going to be a circle or ellipse, something of that sort, like an oval shape where you have the x squared plus the y squared. So let's bring the x over. And what I'm going to do here is complete the square. So if I complete the square, if you guys remember completing the square, you're taking half of b, so b would be 1, and you are squaring it, so we wind up getting 1/4. So just remember, whatever you do to one side of the function, you add to the other side of the function. So that's why this 1/4 is being added to both sides of the function. Next step is, can we factor this portion? Sure we can. So it's x minus 1/2, the whole thing squared, plus y squared equals 1/4. So going back to the equation of a circle, would be x minus h squared plus y minus k squared, and that's equal to r squared. So in our situation here, this is a circle with radius 1/2. I took the square root of 1/4, and it's centered at 1/2, 0. So what we have let's say this is 1, right? Let's say that's 1, -1, right? So if the center is at there's our center, and we have 1/2 is the radius. And we know that we would have a 1.5 unit away from all of these, and there is our curve. So what we basically did was, this is in rectangular, and this is what r equal to cosine theta looks like. So what becomes a lot easier is it's easier to deal with the polar in this situation, because look how simple the function is compared to the rectangular portion, where if you had to solve for x or y, say you're doing derivatives,